All right, boys and girls, welcome back to the drive-through for the final probability lesson. That is in Algebra 2 Academic 2018. Sure, we'll get further and further as we go in the future. This is about probability models, and it's really just kind of a wrap-up of what we've learned, but it's also about how to properly take data into account and how to interpret it fairly. There are people that are amazing with data, and they use that skill to fool other people into making the wrong decisions, and then therefore it would benefit them. And you guys all know about fake news. Obviously, it's like a thing that people talk about, but I wanted to show you this. This is bad language, but this is an actual class at the University of Washington. This is the syllabus, and this is what the class is called. Okay? And I want you to read through the syllabus. Let's look at the chapters. So notice that this is a freshman class. That's what 190 and 106B means. That means it's located within the biological sciences, so that would be probably part of like human psychology. And then it's also in part of the information school, so that would be the statistics school, okay? These are the instructors. There's 180 credits. Look at the learning objectives. Okay, and then here are the chapters. And you'll notice, like, statistical traps, big data, publication bias. What that means is, like, when you read something on ABC, do you understand that ABC owns Disney? Sorry, Disney owns ABC. And Disney also owns ESPN. And they also own Applebee's. They do, they own everything. They own Pixar. They're about ready to, I think they just purchased Fox movie productions, So when you read something on ABC and it talks to you about how great this recent movie is, there's a high likelihood that that movie was made by who? By Disney. That's publication bias. It's everywhere. It's everywhere. Okay? The ethics of calling it fake news. So this is like a real thing. With more and more information available to you, it's more and more important that you guys are able to properly identify whether or not information is valid and was statistically collected correctly. So, for exercise, we're going right into the worksheet. That's really all. There's nothing no formulas or anything like that. So, number one, there are 16 players on a soccer team. The coach wants to choose 3 players at random to demonstrate a kicking drill. She makes a list of common numbers of goals scored by each player in the past 6 games. She chooses the top 3 scorers. It wants us to determine whether the strategies described result in a fair decision. Okay? Well, what was the goal of this? To pick 3 players at random. Which players did they pick? The top 3 goal scorers. Is that random? So I would say, this is not a fair decision. The coach stated that she wanted to randomly pick players, but she picked the players most likely to recently score a goal. The players who don't score or play goalie have no chance of being selected. So now you get kind of an idea of what this theme is for today. Okay? This will be a pretty quick video, especially compared to the last ones. The next thing we're going to do is teach you how to use a random number set or a random number table. I had no idea how to do this. I had to read through the book. There's all sorts of better ways to get random numbers. What's the best way to get random number is just Siri. I just found out you can ask Siri to flip a coin for you. Did you know that?
Yes.
I've used it like all week. You can just say, hey Siri, flip a coin, and she gives you a head or a tail. You can say, hey Siri, I want a random number between 1 and 100. They'll give it to you, okay? But I need to show you how to use these tables, because these tables will show up in statistics classes. All these are a set of random single-digit numbers. Why are they spaced like that? So that you can read them easier. You can imagine if you just had 1,000 numbers jammed together, you wouldn't really be able to read them as easy. And keep in mind that in a lot of these questions, you're going to just throw things out. So a teacher wants to select 4 of the 28 students in her class at random to present their projects. She assigns a 2-digit number from 1 to 28. Keep in mind, 1 is 01, 9 is 09. What are the numbers of the students that will give their reports on Monday? So, she pops up this random number table, and you just look at the numbers. If it's not below 28, you move on. So, 79, skip it. 94, skip it. 44, skip it. 40, skip it. Now we have one. What's the first number that's picked? 0, 1. That's the first number picked. Okay? The next number is 49, 93, 39, 94, 47, 72. 27 is the second number picked. Okay? 98, 82, 28 is the third number picked. So you understand how to use that? It's probably hard for you to see on the board, but hopefully you're looking at your table. So those are the answers to number 3. Okay? So we're just trying to talk about fair ways to pick things. A juice company is having a promotion in which one of the letters J-U-I-C-E is printed on the inside of each of their bottle's lids. Customers win a free bottle of juice if they collect all 5 letters. Each lid is printed with exactly 1 letter, and the letters are equally and randomly distributed. Describe a simulation. So a simulation is like a trial to predict the number of bottles a customer would expect to buy to collect all 5 letters. There's infinitely many right answers for this question. There are also infinitely many wrong answers for this question. Notice we have 1, 2, 3, 4, 5. Since this problem involves 5 random events, I am going to use a dice or a die. Okay? I will consider 1 to be J, 2 to be U, 3 to be I, 4 to be C, 5 to be E. Come on. I will record each roll, and I will continue to roll until I get 1 of each number. Sorry, each letter. Once I spell juice, I will record how many rolls it took, period. I will then repeat that process 10 times and average the number of rolls it took to spell juice. Does that sound okay? You could have also done a random number generator. You could have done a lot of different things. All right, this is our final problem. This is a contingency table. I can tell you right now, this is going to feel a lot like what we did in yesterday's lesson. Okay, so they totaled it for us. So we've got a situation here where they're kind of seeing if a set of software helps the kids do better on a quiz. Okay? So, what is the probability that a student received an A or a B given that he or she used the quiz software? Well, how many students used the quiz software? 13. How many of those students got an A or a B? 8. Okay? I have a feeling we might be comparing these. So I'm going to do 8 divided by 13 on my calculator and get it as a percent. That's 61.5%, about equal to 61.5%. Okay? What is the probability that a student received an A or B given that he or she did not use the quiz software? How many people did not use the quiz software? 13. How many received an A or a B? 9. So that's about 69.2%. A school decides to purchase this quiz software for all of its Algebra 1 students. Is this a good decision? So now we're going to try to interpret this data. What do you think? I would agree. Now, this is a small amount of data, and we also do not know how the groups were picked. Okay? And this is where, like, the real world comes into play. So I want you to open your eyes and ears to this. Okay? Let's say this is definitely not happening at our school, and this definitely happens in the real world. Let's say our principal, okay, or a principal at a school, also works for a textbook company. Many people have more than one job. Do you understand that? So let's say this textbook company uses, can you guys just quiet down for a second? Let's say this textbook company uses our principal. Have you guys, sorry, so let's say they hire this principal as a consultant. Have you ever heard of consultants? Consultants have a lot of experience in a field, so they are paid a lot of money to give professional advice to groups of people to help make decisions. They consult them. Okay? Well, let's just hypothetically say that the principal worked for a consultant, as a consultant, for a textbook company. And as a consultant, that principal was paid based on how many people he got to sign up for this textbook. Does that make sense? That's how the world works. So what if the principal grabbed the smartest kids in the algebra class and had them use the quiz software? And then they took the kids in the algebra class that weren't as smart and have them not use the quiz software. I'm not saying this happened. This did not happen in this situation, okay? And then the results showed that the software made a huge difference. What would the school then be inclined to do? They would buy the textbook software. And then who would make money from that? The principal would, the consultant. And this is real world stuff, not here at our school, but like this is what lobbyists do. This is what salesmen do. Okay, I'm not saying they're bad people. I'm just saying you've got to pay attention to how the data is collected. Got it? Thank you. Boom!